Hey y'all. Okay, so right now we are going to do a problem from 9.3. So this is a 9.3 problem. It's basically like 9.3 continued. This is in the homework where it'll ask you if a number is a solution to an equation. And what it wants you to do is actually plug that number in for the unknown variable and then solve it. And then it's yes or no, true or false. You want to know, is it a solution? So say if it asks you, is 9 a solution to 9x plus 7 equals 92. So our equation is the 9x plus 7 equals 92. And it's asking me if 9 is a solution. So what this is saying is my 9 is going to be my x. Okay, so let's plug it in like that. So we would have 9. And then because that x is multiplying this 9, it's saying that you need to put it in parentheses. You wouldn't just write 99. Like it doesn't just replace x and now you have the number 99. That's implying multiplication. So it's 9 times 9 plus 7 equal 92. I think it's good practice to put a question mark there. We don't know if that's true. That's what we're trying to see, is if that's true. So if you do 9 times 9, you get 81 plus 7. Is that the same as 92? If you combine those terms right there on the left, you get 88, which is not equal to 92. So your answer would be no. 9 is not a solution. Okay? Okay, so now we are going to plot some numbers on a number line. Okay, so plot numbers on number line. In the homework, it will already have a few number lines, and it'll like go up to a certain amount of numbers depending on what it wants you to plot. It'll look something like this. Oh, okay. Say it'll look something like this. It'll say plot these numbers on a number line. -5, 0, and 3. So again, on the homework, it'll already have a number line. 5, 4, 3, 2, 1, 0, 2, 3, 4, 5, 6. I just randomly threw some up there, enough to where I know I'm going to have enough, but just threw some numbers up there. Let's go ahead and say we make this right here our 0. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, on my math lab, these are already numbered, okay? So it's literally just figure out where this number is on the number line and then plot it. So if we do this, I know that my -5 is negative, so it's smaller than 0, so it's to the left of 0. It's actually right here. And then if I plot my 0, it's right here. And then my 3 is right here. And then you would just hit submit. This is a visual representation of me being able to see where numbers lie on the number line. If a number is to the left of another number, it means it's less than. And if a number is to the right, it would mean it's greater than. So because my 5 is on the left-hand side, -5 is on the left-hand side of 0, then we know that -5 is less than 0. And then because my 0 is on the left-hand side of my 3, I also know that 0 is less than 3. And then say I went the other way with it. Say I wanted to point out that my 3 is on the right of 0. So I would know that 3 is greater than 0. Okay? Let me see here. Okay. So that right there kind of brings up a good point. In the homework, you will actually, didn't mean to open that up. You'll actually be asked which is lesser. Lesser, same thing as smaller. Less than could be a way you could read it. And for an example, say on the homework, it tells you the number -3 or -4. And it wants to know which is lesser. So usually when you're not dealing with negative numbers, you automatically know it's kind of something you don't really have to think that much about, right? You automatically know that the number 3 is less than the number 4, right? But because we are dealing, oh yay, because we are dealing with negative terms, you need to make sure that you look at the number line. Okay, so if you notice 3, let me plot that in green. My -3 is here, and my -4 is here. So my 4 is to the left of that 3. And if a number falls to the left of a number on the number line, it means it's lesser than, it's smaller than. So the answer would be -4. It is kind of backwards. When you're looking at negative numbers, the smaller one is the larger numerical value. If you think about it, if I have -$3 in my bank and then I spend $1, now I'm -$4. So I'm now more negative. I've gotten even less money than before, right? Let's see about -9 or a -13. I'm going to tilt my computer just a little bit better. Do -9 or -13. So like I said, with negative numbers, if you just look at the numerical value, 9 and 13, you just look at those numbers. If you're trying to figure out what's more smaller, it's going to be the larger the number is. The larger the number is, the more you're getting smaller. Basically, the more you're going to the left of your number line. So you're getting smaller and smaller and smaller. You're getting further and further away from 0, right? So this would be -13 is less than my -9. Okay. What about this? Say we're asked a -4/5 or a -1/3. I've not figured out how to pull up a handy dandy calculator app on this just yet, but I'm going to tell you right now, if you put into your calculator -4/5 and you hit enter, it should show you -0.8. Okay. And then if you put -1/3 and you hit enter, it's actually going to be a repeating decimal. So you can put a line on top of it if you want. We're really only concerned about this first value right next to the decimal, which means it's in the 10th place. So technically, I just rewrote it as decimals. And what I'm looking at now is just numerically, what's the largest number? And I would get 0.8. That means I'm 8/10 away, 8/10 units away from 0. And then if you look at the right-hand side, I'm only 3/10. So 8 is larger. I'm getting further away from 0 on the number line. Okay. Hopefully that makes sense. If it does not, let me know. Thanks, y'all.